Welcome to Basics of Cashu Wallet Development with cashu-ts, an introductory workshop to get started with Cashu development, probably. This workshop was initially called Basics of Cashu Web Wallet Development, but then we realized that we might have some overlaps with the workshop that's right after this one. So I'm going to cover the very basics of building a Cashu wallet with TypeScript today. How we interact with mints, and then Goodenough, right after me, is going to go a little bit more into detail and integration into real-world applications. So if you have never built a Cashu wallet before, you might want to stick around for both workshops to get the whole experience, basically. There are some soft requirements. One is basic TypeScript and Node.js knowledge, and also some understanding of ecash in general. I think we are on a pretty good level already. I'll have some, very basic primers ready, some Cashu primers ready in a couple of minutes. So we are all on the same page, but it definitely helps if you have some understanding of ecash. Those are soft requirements, so if you do not fulfill these requirements, don't worry, you will still be able to follow along. Everything should be quite easy to understand. Short slide about me. My name is Egge. I am class of 21, Cashu contributor. I built npub.cash, your friendly Noster Cashu-based Lightning address. And I'm also a cashu-ts maintainer, which is part of the reason why I'm here today, telling you about cashu-ts and how you can use cashu-ts to build a Cashu wallet. If you want to get in touch, you can do so on Noster. This is my NIP5, egge@npub.cash. You can also message me on Twitter. I'm very, very bad at responding to direct messages, so please, please bear with me on that one. But feel free to reach out. Feel free to just catch me here as well. If you have any questions after this workshop, happy to answer all the questions. All right, so about this course, we have two main goals. First of all, we want to understand how the Cashu protocol in general works. As I said, I have prepared a small primer for everyone to get on the same page. But then we want to learn how we can use cashu-ts to help us interact with Cashu mints. All the slides and the code and the practice project that we're going to work on in a couple of minutes are open source. They are available on my GitHub. Both repositories are named something btcplusplus24. You should be able to find them quite easily if you just go to my GitHub profile. Regarding the slides, actually I do have two different presentations prepared. One is the primer and one is the code examples and everything. So on the btcplusplus24-slides repository, you'll find a content directory that has all the code workshop stuff as a markdown file in it, as well as these slides as PDF file. So if you want to check out the course after this workshop is concluded, you can happily get the slides there. It's not really required that you have the slides open. I will keep them here, but if you want to read them on your own device, make sure to get that repository cloned. All right, what we're going to talk about today, intro is what we're doing right now. We're going to talk about the Cashu protocol basics, as I said, as a primer to get everyone on the same page. We're going to discuss the cashu-ts setup. We're going to talk about the Cashu token, and then we will handle sending and receiving, and this is both ecash sending and receiving, as well as the interop with the Lightning Network. All right, so let's get started with the quick primer on the Cashu protocol basics. I'm not going to cover cryptography here. That's one of the great parts about cashu-ts. It handles the cryptography for you. So that's why I said it helps if you understand ecash on a basic level, because we're just going to talk about the Cashu protocol real quick. Cashu in a nutshell. Cashu is a crypto and communication protocol between servers and clients. The most easy way to say it is basically Cashu is a Cashu mint is a web server and a wallet is a client. And what the protocol is, it defines the messages that we send between the servers and the clients. So this is the usual interaction that you will see when building Cashu stuff. You have a wallet that talks to a mint, but obviously the ecosystem has a lot of more stuff happening. Wallets can send directly to each other. Mints you can maybe settle debts between mints. But actually, the Cashu protocol itself only defines the communication between a wallet and a mint, and everything else is kind of undefined and happens through whatever gateway you want to have. Like the mint-to-mint interop is done through Lightning, and sending one token from one wallet to another wallet can be done via email or via QR codes or whatever method you want to have. So the Cashu protocol itself focuses on the communication between the wallet and the mint only. And this is actually how it looks like, right? So as I said, a mint is nothing more than a sophisticated web server that exposes a web server API that has a couple of endpoints that you can use to do stuff, right? You can, and these are actually all the things that we're going to do today. So you can get some info about your mint. You can read the key set. We're actually not going to do that today because we don't need to, but you could read the key sets. You can mint tokens, you can meld tokens, you can swap tokens, and so on. So all of these are just very, very simple RESTful API endpoints that you are able to talk to as a wallet. And the cool thing about cashu-ts, and one of the reasons why I like the library so much, is it basically takes all of that away, and you don't have to worry about that. And that's actually what we are going to do now. So, cashu-ts. Cashu-ts is a TypeScript library, and as I said, it takes away a lot of the complicated stuff about Cashu development. I mean, Cashu development is not too complicated, but it is complicated sometimes, and cashu-ts helps you deal with that a lot easier. It takes care of the underlying cryptography, as I said. You don't have to worry about how blind signatures work. It will do it for you, and it provides a declarative API for using the protocol for interacting with a mint and so on. Something that I would just want to mention, it definitely makes sense to understand the cryptography that's underneath everything. And it makes sense to understand how the protocol works on a deeper level to maybe solve problems more easily. So if you want to do that, as I said, I'm not going to cover this today. We have an hour, and there's only so much you can cover in an hour. But if you want to learn more about Cashu, there's the nuts, which is basically all the specifications of the protocol. They are open source, available on GitHub. So if you want to learn deeper about how the cryptography works, about how every single of the endpoints that I've just shown you works, how the responses look like, and everything, you can just look that up on the Cashu repository in the nuts repo, and you will find specifications and test vectors for pretty much everything there. All right. So I have prepared a practice project. We're going to set up a very, very simple CLI application today. There's absolutely no state in the application, so we're not going to cover more complicated stuff like how do I store tokens on my device, like how do I select the right tokens and so on. How can I interact with multiple mints at the same time? We're not going to cover that today. We want to learn about the basics, so it's a stateless application, quote unquote. If you want to work along, you're invited to do so. Depending on the time, I was planning to do a back and forth between you writing code and me showing the solution, but I think because we only have the 60 minutes, we're just going to do some live coding, and you can follow along if you want to. So in order to set up this practice CLI project, you would clone the repository. For everyone that can't read the link, it's github.com/egge21m/btcplusplus24-code. Or you can, as I said, just look up on my personal GitHub profile. You will find the repository there. And you will clone that repository down. And once you have that, you just change directory into that fresh directory. Make sure to check out main. It should be checked out by default. And then you can run an npm install to get everything set up. There's some boilerplate in that repository. As I said, we're building a CLI application. You don't have to worry about building a CLI application. It's pretty much done. You will just have to fill out the blanks, so to say. The only thing that is missing in this project is cashu-ts itself. So if you want to install cashu-ts into this project or any project you want to install it to, you can do so with npm install @cashu/cashu-ts. All right. There's also nodemon in this project, so you can basically, whenever you do a change, it transpiles the TypeScript code automatically to JavaScript. Not a requirement, but if you want your machine to do that, you just open up a terminal and do npm run dev in that repository or in that directory. So every time you change a line of code, it will try to build the application on its own. Yeah. All right, let's get started with the basic API of cashu-ts. Cashu-ts, as I said, TypeScript library, has two main classes that are exported that are pretty much used for everything. Right? We have the Cashu Wallet and we have the Cashu Mint class in cashu-ts. And these are the two classes that we use to interact with a mint and do all the different wallet operations that we have. There's also a bunch of utility functions exported, something like get encoded token. We'll see how that works later on. But most of the mint and wallet interactions you're going to do are methods on one of these two classes. So setting these up is pretty simple. And this is a code pattern that we're going to repeat over and over and over today. Usually you would probably write some code to have a static reference to a Cashu wallet or something. But for this application, as I said, we try to be very stateless. So we're going to write these 3 lines of code. Actually, mint URL is a global constant in the project, but these 2 lines of code, the mint and the wallet declaration, we're going to write those over and over again, and you do that all the time, right? So you instantiate a Cashu mint, give it a URL, the mint URL. The testnut.cashu.space is actually live, so you can test that as well. There's no real money involved. We call it fake nuts. So basically, you get Cashu token when you interact with that mint, but those are backed by nothing. Every single Lightning invoice that this mint will give you is not a valid Lightning address. It will be paid automatically within seconds. So it's a great mint to just play around with. There's no real money involved, and we're going to use that mint in our workshop today, and I hope it takes the traffic. We'll see. But yeah, so basically you instantiate a Cashu mint class with a mint URL, and then you instantiate a Cashu wallet class with a reference to the Cashu mint that we just instantiated. And then you can do all the stuff like minting tokens and basically all the stuff that I'm going to show you in a couple of minutes on these 2 classes. All right, so let's go through the API, the Cashu API step by step, and how we can actually interact with these endpoints using cashu-ts very easily. So the first thing that we're going to start with is actually not minting or anything token related, but we want to get some information about the mint that we are connecting to. This might be very useful for building user interfaces because you can give some human readable information about the mint to your users. At the same time, it is also required for your programmatic stuff to work because the info endpoint will return a JSON struct that has information like name, description, but also which nuts, so the specifications basically, are supported by that mint. Not every nut is mandatory. There's a couple of mandatory nuts that every mint needs to implement to be compatible with the protocol, but there's also some optional stuff, for example, WebSockets. WebSockets are not mandatory. They don't need to be supported by every single mint, and if your app relies on WebSocket connections, you might want to check, does this mint actually support WebSockets? And if it does not, you might want to give the user an error message saying, hey, this mint exists, but you can't use it with this application. So the info endpoint is actually very important, even though it's not related to ecash. Yeah, so the info endpoint, as I said, just returns JSON data, so you could just do a fetch call and get the data yourself. But cashu-ts does export 2 methods, expose 2 methods to get the info as a JavaScript object. And there's one on the Cashu mint class, and there's one on the Cashu wallet class. The Cashu mint class is get info, and the Cashu wallet class is get mint info. And actually, this is the only time today that we're going to do something on the that we're going to call a method on the mint instance directly. Usually, all your interactions will be on the wallet class. You can actually do a lot more in-depth stuff with the mint itself, but for the basic interactions, you usually just use the wallet instance. So I would recommend in this case just go with the wallet, go with the wallet one, because it is the most used in this course. So you call get mint info, it will get the info endpoint from the mint and will return the info as a JavaScript object. Just checking the time here. So yeah, let's do that really quickly. Actually, I do have the setup mostly. I do have the project mostly set up already. Just going to make sure that I have all the dependency installed.
Can you zoom in?
Oh yeah, right. Sorry. Is that better? Okay. Okay. So I'll take this as an opportunity to go through the project structure really quickly. So this is what you see when you clone down the project. We have the source directory that has all the source code in it, typical TypeScript setup. And in here we have an index.ts file, which is our entry point. You actually don't have to do anything in this file. It is just the boilerplate for the CLI that we're building. So every single thing that we're going to have today has its own CLI command, and it has its own CLI handler function. And those handler functions are the ones that we're going to edit actually. So all of those are in commands, and you can find them here. And as I said, we're doing the info thing right now, so let's open info.ts. And in here, you have the boilerplate code that outputs the data once we have it. So now we have to write that code, basically. So as I said, pretty much every time that we're going to do anything, we're going to start with instantiating a cashu mint. And we're going to pass to it the mint URL. In this project, mint URL exists as a constant exported, so you can just get mint URL from the constants.ts file. It is, as I said before, it is simply the testnet one. In this case, it's the nofees.testnet.cashu.space, which is a special one that doesn't have cashu fees because we don't want to deal with that here. But yeah, so for this project, you can just use that constant. Yeah, so and just do that again. So we're going to instantiate a new cashu mint and then pass to it the mint URL. And then we're going to instantiate the wallet and pass to it the mint. And as I said, this is something that we're going to do a lot. And all that we need to do in order to get the info is call the getMintInfo method on the wallet. So in this case, I expect the info to be assigned to the data constant. So I'm going to do const data, and then in this case, await wallet getMintInfo. Okay, so as I said, we are talking to a web server on the internet. So basically, everything that we do will need to be awaited. There's a couple of utilities that run locally that don't need, but most of the methods that are exposed by the wallet class have to be awaited. They will return a promise otherwise. So yeah, so this is actually it. So now we can go ahead and, as I said, we can do npm run dev to run our dev server that will just, or not dev server, but basically our automatic transpilation. And once we have that, we can call the thing that we're building using this command, node cashu.js, which is the index file, and then we pass to it the info command. And now we get this out. So actually it is set up in a way that when we pass the R flag to it, it will give us the raw data. This is the object that the mint returns on the info endpoint. And as you see, it contains the name, it contains a pub key, the version description, and so much other information. And also the nuts key contains information about which optional nuts are supported by this mint. All right, so far so good. This is working. So the next part is probably the most interesting part to everyone here, is minting a token. So in Cashu, when we create a token, that's what we call minting. And minting is a multi-step process, actually. So when you want to mint a token, you go to the mint, say, hey, I want to mint a token for a specific amount. And the mint returns something which we call the quote. The quote is actually information how we can pay this token that we just, the mint that we just requested. So we get back a Lightning payment request in this quote. Then we go ahead and pay the payment request, and after we paid it, we can go back to the mint and say, hey, I paid this quote, please give me the token that's associated with this quote. As I said before, the test mint that we're using does not have real money behind it. So we will request a quote from this mint. It will return a quote. It will also return a payment request, a Lightning payment request. We don't need to pay that. It will be automatically paid after a couple of milliseconds, actually. So this is usually what we would do, right? So we instantiate the mint and the wallet again. As I said, we're going to do this a lot. And then we can create this quote with the method called create mint quote. Create mint quote takes the amount of sats that we want to mint as a number. And once we paid it, we then go ahead and call the mint tokens method. And we give it the number of tokens, the amount of tokens that we want to mint, basically the amount in sats, as well as a reference to the quote ID of that quote. Now the tricky part is you can only mint the tokens after the payment has been done, right? So you would usually implement some sort of loop or polling in order to check whether this payment has been made. There is WebSockets now in Cashu. However, WebSockets are not yet there in cashu-ts, so there's no way to get notified of a payment being made. So usually what wallets would do is would just poll the mint, check if the quote has been paid. In this case, we do know that the quote will automatically be paid, so we can just sleep for a couple of seconds and then check and then mint the token. So for this step, we're going to go into the mintiest file, and it has the boilerplate already here. So we have the mint and we have the wallet instance. So now what we're going to do is we're going to get our mint quote by calling await wallet create mint quote, and we're going to create a mint quote for 21 sats, and then at the end stage, or like at the end, we would call await wallet mint tokens, and mint tokens takes the amount again, as well as the reference to the quote ID, which is in mint quote in the key quote. So as I said, we want to sleep for a couple of seconds, or we could also let's just wing this here and build a loop real quick to do some polling. I don't think we'll actually do polling because the fake mint just immediately marks this quote as paid. But what you would do is you would basically say, okay, I want to check the mint payments at the quote payment state, and you can do that with another method called check mint quote. This also takes the quote ID, and so this and then we're going to do something like this. Okay, so this is what it would usually look like. You would call check mint quote to get an answer from the mint if this quote already has been paid, and if it has been paid, you could break out of the loop. You could also implement some timeouts, whatever you want. Now, if we do this, we would spam the mint quite heavily with requests. So we don't want to do that, and this project actually has, because JavaScript does not have a sleep method like Python does, for example, we do have a sleep utility, which just returns a promise that will resolve after whatever seconds you want. So in this case, I'm just going to say sleep for 2,000 milliseconds, and then repeat the loop, and whenever we get the state paid, we break out of the loop, and when we break out of the loop, we will call mint tokens. Everyone follow this? Awesome. All right. Okay. So let's also, just to see this in the console, add a console log here. Okay. So Yeah, this should work. Yeah, so we can just go for the next command, which is the mint command, and let's see if this works. Awesome, this did work. So we see the quote has been paid. As I said, we are not actually polling because the fake mint just marks the quote as paid immediately, even though we did not pay. Usually you would have time to go grab your Lightning wallet, pay the invoice, stuff and like that, and afterwards our promise resolves, or like our while loop breaks in this case, and we see this. So this is not your regular cashu token, right? If you have seen a cashu token before, this is usually not what it looks like, and it's actually not very user-friendly to show this on a device. This is kind of the central piece of a cashu token, and it's the proofs. The proofs contain the cryptographic information that we actually need to verify, or like that we need to prove, that's why it's called a proof, that we own this token, that the mint created this token. So it has the unblinded signature of the mint, which is C, and it has the secret that has been used to generate this token in the first place. So this is the information that is required to prove the ownership of the token. And it is, as I said, the central piece of every token. However, we need some more metadata and also need to make it kind of usable in order to display it on the front end, right? So this is actually where the... Oh, I actually had this in. Yeah, so this is the loop. So the next step is the autonomy of a cashu token and to learn how that actually works. So this right here is still not the thing that you're used to from looking at your Cashu wallet. However, this is the unserialized version of this. As you can see inside of this object, we do have the proofs array that we just saw in the console with the proof of ownership basically. But also we have some metadata around that proof. So for example, we can attach a memo for a wallet to display. But also, very important actually, we have the URL of the mint that this token belongs to. Because even though there is mint operability, a token that was minted with mint A cannot be directly spent with mint B. So it's very important for a wallet that receives a token to know where does this token actually belong to. So this is the unserialized version. And then the things that you're probably used to from your Cashu wallets are these long strings, right? So we have the Cashu A string and we have the Cashu B string. And those are actually the serialized and encoded versions of this object that we've just seen a slide before, right? So there's two different versions right now. So V3 is the generally supported version. V4 is the little bit more bleeding edge version. It is CBOR encoded, so no longer we do JSON serialization and encoding. We do CBOR encoding, we do CBOR serialization, and then base 64 encoding. The token is just a lot smaller. It's much more dense. You can't really see this here because it, for some reason, cuts off the line, but it is like, I think in this case it's like 60% of the size. But yeah, so we're going to learn how to do that because, of course, cashu-ts provides all the utility functionality that we need to do it. And that's actually very, very simple, right? So we have 3 utilities. Those are not on the wallet instance. These are just standalone utilities exported by the module. We have get decoded token, which takes a serialized and encoded token and gives us this raw output that we just saw in the console. And then we have 2 get encoded token functions, one for the V3 version, which is the standard version right now, so it's called get encoded token. And then for the more bleeding edge version, V4, get encoded token V4. And for this, I have another file prepared, obviously. And this is the token file. Token.ts, and it actually has some data prepared already. So there are some proofs in there, and there's this token object that we've just seen before. As I said, it contains an additional memo. It also contains a reference to the mint URL. And this is actually, that might be important, this format is not spec'd, right? So this is what cashu-ts decided to do internally to be able to handle different token formats in one single standard. So every single method will be able to operate on this token type that we have here. But this is not, the a cashu v4 raw object looks way different than this, but cashu-ts still translates everything to this format. Actually, as you see here, we have a console token, and inside that object is a key called token, and the type is called token. And when we talk about cashu tokens, we always talk about token. So, in my personal opinion, this is maybe something where we can improve a lot by making sure that things are named more specifically. So the spec, I don't think anywhere in the spec we actually mention token. So token is kind of a word that we just use to describe everything that we don't have a word for, which is not ideal. But again, like, please bear with me at this point. Work in progress, right? No, but yeah, so this is the structure that you will just have to use using cashu-ts. You can look at the token type to understand how it is structured, but as I said, it contains the memo and then another token key that then has an array of token, right? These are sometimes called token entries as well, but I don't want to confuse any further. I already did a lot, probably. Okay, so let's encode a token. Decoding a token is actually pretty simple. We just take the string and put it into get decoded token. So we're not covering that, but you can try it out on your own. And I think there's a couple of functions that will do it later, but actually it doesn't need any explanation. So let's encode a token. And yeah, in this case, we want to do two different things. We want to do the CBOR one, and we want to do the normal one. So for the CBOR one, as I said, we are just yeah, we're just so encoded token. Actually, this doesn't need a lot of explanation as well. So we are just calling get encoded token before, and then probably logging it to the console as well. And so if we don't want to get the CBOR token, we're going to do the regular get encoded token and pass in token. So the CLI tool actually does not allow you to like pass in a token or like pass in a token object from the CLI. I didn't do that because then you have it as a string, you need to format it and everything. So this is why I had the token variable defined here, so we can use that in order to make sure that our code works. And we, as I said, we're taking the two utilities with that token that we have defined, and then outputting. I need to output this as well. Then outputting the tokens to the console. Yeah. So let's try this right here. So this command is called, not token, it's called encode. Yeah, so we took the raw token that we have defined as token inside our file, and we made this cashu-a token from it. And actually, now you will see how much smaller the CBOR one is. So if we give the flag CBOR with it, we will go the other route in our function and get the CBOR token, and you can see it's 8 lines versus 5 lines. So there's actually a lot of room saved, even though it is exactly the same data encoded. So we had the same input, but we got two very different outputs. So yeah, this is cashu token and the encoding of a cashu token. So so now we can actually go back to our mint handler that gave out this weird proofs structure that we had before, and we can actually make sure that our mint command returns something that we can work with, like an encoded token, right? So we're just going to open up our mint function again, and so we learned mint tokens does actually not return a token how we think about it. It returns an object with the proofs key. So I'm just going to use object destructuring to get the proofs out of this call, and then instead of, yeah, then we're going to define our token ourselves. So I'm just have the type here, so TypeScript will tell me if I do something wrong. But yeah, so we have the memo key. And then we have the token key, which expects an array of tokens. In this case, we'll just have one that has the mint key, which is the mint URL. And this is exactly what we did just before, but I'm doing it again, so we have it in the mint method as well. And then we have the proofs, and we don't need to assign that because the variable is called proofs already. So we can use the shorthand in this case. And then instead of outputting that object, we want to get a v4 token. Okay, so now the same method that we used before should now, instead of giving us this, what it gave us before, it will now give us an encoded token. So let's try that. Boom. Okay, so now we minted a cashu token using cashu-ts, and the output is actually the thing that we can display in our wallet as no longer that weird JavaScript object that users cannot use, right? So pretty good. All right, so sending a cashu token is the next step. And I know this is quite quick-paced. I want to get some info out in a little time. If you have any questions, feel free to just raise your hand and interrupt me if you want to. But yeah, so we want to cover all the basics. So sending a cashu token. Sending a cashu token is just handing someone else the data that we just encoded, right? Actually, you could hand them the raw JavaScript object as well. They could use that as well. But we do encoding, so you give them the encoded token, and the problem is that if I have in my wallet, let's say, a single proof worth 64 sats, and I want to pay someone else, I don't know, like 16 sats, I cannot do that right away because I only have that single data piece, right? So I would hand them 64 sats and now I would have overpaid. So what we do instead is we do swaps. So if I know that I'm going to pay someone 16 sats and I only have a single proof of 64, I would go to my mint and actually swap my 64 sats for a variety of smaller proofs, basically. So here we have this example, right? Alice has a 64 sat proof. Bob wants 32 sats. So Alice contacts her mint and is like, hey, I want to swap my 64 sat proof for many smaller ones. And the list of numbers that you see here, 32, 16, 18, 4, 2, 1, and 1, make up 64 as well, but now Alice has smaller denominations and smaller proofs. So basically you can think of like dollar bills, basically, right? Or like change. So now Alice can go ahead and encode a new token, not using her 64 sat proof, but instead using a 32 sat proof and a 1 sat proof, which adds up to 33 sats, which is exactly what Bobs expect. So we cannot simply send everything. We might have to look at our wallet first and which proofs do we have that actually satisfy the requirement. If we don't have any that satisfy the requirement, we need to swap them first. And in cashu-ts, that's actually very simple because we do have a send method. I'm not sure why it's not highlighted. I'm pretty sure no one can read this, right? But I'll show it in the editor in a minute. We have a send method on our wallet that takes in an amount that we want to send and any list of proofs. Doesn't matter if it needs to be at least the amount that we want to send, but if we overpay, it doesn't matter in this case because the send method will return two things. It will return our change as well as proofs to send, so that we can just take the proofs to send, encode those, and send them away. So back in our editor, we're going to open up the send.ts file. And the send.ts file actually has another utility here, which is called mock get proofs from DB. As I said, this is stateless. Usually you would look in your own wallet and would get proofs from your own wallet. In this case, this function simply always returns a single proof worth 16 sats, right? So actually in the back, it is minting it directly from the mint. We don't have any storage here. So, but yeah, you can assume this is your call to your local NUT database, and you get the proofs from there. So in this case, we want to set Bob 9 sats, but we only get 116 sat proof from our database. So what we need to do is we have to call, as I said, await wallet.send, and we want to send 9 sats, and the proofs that we're going to send is already assigned to the proofs variable. And this is going to give back 2 different things. It's going to give back the return change, as well as something called send, which is just a list of proofs matching the number that we specified as amount. In this case, a list of proofs that add up to 9. So I expect this to be called to be sent. So I'll just reassign that variable name real quick. To be honest, sent wasn't the best choice. We might change that in a later version. But yeah, so this is basically it. That's how easy it is to have whatever amount of proofs you have in your local store and send it to someone else, swapping it beforehand, because cashu-ts takes care of that. And yeah, we can actually also, because in this case we're just console logging the encoded token again, but we can also just really quickly console log send, so we see the proofs. I called it to be sent, right? So we see the proofs that we're going to send. So I'm going to save this, go back to our terminal, and now use the send command. Going to take a minute. Cool. All right. So this is exactly what I said. We get the 16 sat proof from our database. We pass that proof to the send method. We say, hey, return as variable to be sent, return proofs new proofs swapped from the mint that add up to 9, because we want to send 9. And this object right here is what we get back from the send method. It's an array of proofs that add up to 9, and then we encode it to a token, and now we could ship that token to the user interface, and someone could scan it as a QR code or send it via email or whatever. All right. Receiving. Receiving sounds very simple as well, right? Someone hands you the code, now you have it, right? You have those proofs. As I said, the cashu token encodes the proofs, so as soon as you receive that string of text, you have the proof, right? The problem is with cashu, there's the risk of double spending, because not only you have that string of text, the sender also has it, right? So until you actually do something with it, you both have that token at this time. So we can only assume something as received once we go back to the mint and invalidate the old token. How do we do that? We use the same endpoint that we just used to create a smaller denomination, which is the swap endpoint, which just allows us to give the mint a proof and get back a new one. But in this case, we don't even need to change the denomination. We might want to. Maybe we say, hey, pay me 100 sats, and that person decides to pay us 100 sats and one sat proofs. So we would have a list of 100 proofs in that single token. We might want to consolidate. But we definitely need to swap it. And when we swap it, we give the old token to the mint and get a new token. And the cool thing about that is the new token is only known to us, right? So the sender sends us something, we both know it, we swap it for a new one, now only we know it. And only then we can actually think as something of something as received. And we do have a very easy method for that as well. So this is how we do it in cashu-ts. We call await wallet receive. We give the proofs that we just received, and we get new proofs out. Right? So that's really, really simple. And again, we're going to do this here. We do have a receive. Oh. We do have a, where is it? Receive file. Same setup as always. And we do have another utility that will actually show us the amount that we received. But now the only thing that's different here is we can actually use our terminal to get the token in. Right? So receive handler receives the token that we want to receive as an argument. So token is basically passed in by the CLI. And in this case, we can go ahead, because the token will be encoded, right? First of all, we need to extract the proofs from that token. So we start with decoding the token. by calling the get decoded token utility. It's really easy. As I said, you just pass in the token, the encoded token as an argument, and you get the JavaScript object out. And now we can say we're gonna call it proofs. So we're gonna say await wallet receive and put in decoded token. I'll just check if it actually even takes a token as an argument. We don't even need to decode it in this place. I'm sorry, my slides are wrong in that case. So we can even do this and just pass it a token string and get the proofs out. So let's see if that works, because obviously I made a slight mistake writing that slide. So I'm just going to copy the token that we just created for sending. I'm just going to copy that here in the CLI and say receive and then paste this one in. Let's see if that works. It does work, right? Okay, so now we take in a cashu token, encoded token string. We pass it to our wallet receive function. It takes the token, it decodes it automatically because cashu-ts does it behind the scenes. It extracts the proofs, the old proofs from that token, gives them to the mint and says, hey, please give me back new proofs for the same value. And now these are the proofs you see here in the console are the new proofs that are only known to us, no longer known to the sender. So this is how we receive. Okay, there's one last thing that we need to learn. So now we know how do we mint tokens, how do we send tokens, how do we receive tokens, how can we convert a encoded token into a decoded token and vice versa. The last thing that we're going to learn is how to melt a cashu token. And melting is a little bit more complicated from the concept. So melting is actually like destroying a token to get sats, like Bitcoin Lightning sats back out, right? So just like minting, it is a multi-step process that involves the quote. So we get a Lightning invoice that we want to pay using our mint and our cashu tokens. So we get the Lightning invoice, we give that Lightning invoice to the mint and say, hey, dear mint, I want to pay this invoice. The mint looks at the invoice and might also probe the network and then return to us, okay, you can pay this, you need to give me the amount in token, but also you need to give me a fee reserve, right? Because Lightning payments might have a fee, they most often do. So if we want to pay an invoice that's worth 100 sats, we can't give the mint 100 sats because then it would make a negative, right? Because it has to pay the fees for the transaction. So the mint will actually tell us, okay, I'm going to pay your invoice, but you also, additionally to the amount of money that you want to pay, you also have to include a so-called fee reserve. And the fee reserve, as I said, is calculated by the mint. It will be part of the mint's response. So we actually have to send proofs that equal our amount that we want to send plus the fee reserve. And it's called a reserve because actually the mint can give back change on this. So if the mint says this Lightning invoice is going to cost approximately 10 sats to pay, but then it pays it and it sees, okay, that payment actually only costs us 3 sats, it actually has the opportunity to give us back some change, right? So that's why we call it fee reserve. You might get some change back at the end. We will not get back change today because we are not paying real invoices. And the fee reserve on this fake nut mint, on the test nut mint, those are always 0, right? So there's no fees, no fee reserve, therefore no change, and we don't even have to put a fee reserve on top. However, we're going to still do it in theory, for example. So the first thing that we're going to do is just like we did with the mint, we're going to call create, this time melt, quote, and as an argument give the Lightning invoice that we want to pay. Then we're going to calculate the total amount that is required to pay that invoice by adding the fee reserve that got responded by the mint for that invoice to the invoice amount itself, right? So that's our total amount. And then, before we actually melt the token, we might want to call a send, right? This is a little bit confusing because we're not actually sending cashu tokens. Well, we are, but to the mint, not to someone else. But we can use the send method in this case to do a swap in order to pay that amount Exactly, right? So again, if I have a single quote that's 128 sats, and I want to pay a Lightning invoice for 100 sats that has a fee reserve of 3 sats, I want to pay 103 sats. I only have the 128 sat proof in my storage, so I need to swap it again, right? And this is why we call send, give it the amount that we want to pay, which is invoice plus fee, give it the proofs that we want to send as well, and we're going to get the return change that we can put directly in our pockets because we don't need that for the melt. And then we have the to be sent proofs that we then can, in the next step, pass to melt tokens, which will take the quote that we initially created with the create melt quote method, as well as the proofs that we just split. So only the part that is not our change, and we can then call the melt tokens function. Important to note, this will block until that payment actually is done, right? Which can take a very long time. There also is there is an opportunity for error here because it might time out after a while and things like that. Usually these payments are quite quick, but in the implementation how we have it today, this call will actually block, or like it will not block your thread because it's JavaScript and it's async await, but it will actually suspend this function. It will await the payment being made. So after that happened, this will resolve, the promise will resolve, and we can test with checking is paid on the payres variable if that Lightning invoice now actually has been paid, or if there was something else why the mint stopped the call, so to say. And if the mint actually returns some change, in this case it won't because no fee, but if it would return some change, you would also find the changed proofs on that payres object. So as a last step, let's just do this in our project real quick. Go into the melt file and do exactly what we've just discussed. So here we will see that I actually called create mint quote first. This is not because we're minting tokens. I just need a Lightning invoice, and create mint quote returns a Lightning invoice. So I'm basically asking the mint for an invoice to pay. Usually you would not do that, but that was the best way to just get a Lightning invoice, a valid Lightning invoice quickly. So yeah, I get that invoice. I get the proofs from my mock database again. So we start this function with an invoice as well as some proofs. So now the first thing that we want to do is we want to get the quote by calling await wallet create melt quote, and we pass it the invoice. And this quote object will now have the fee reserve as a key, as I said. So we can also go ahead and calculate the total amount, which is in this case 2 plus the fee reserve returned by the mint. Now we're gonna create our return change as well as send. Again, I call this proofs to be sent, calling await wallet send. In this case, we want to send total amount and the proofs that we got from our database. So now we have the split. Basically, the proofs to be sent are the proofs that we want to melt, and now we can finally call wallet.melt tokens with the quote that we initially received, as well as the proofs to be sent. And if we now go back to our terminal and for last time, sorry? Oh, my prettier will do that automatically. So yeah, so for last time, if we call now node cashu.js melt, it will take a while, and we see payment successful. And this down here actually is the payment response that we'll get from cashu-ts that will say it is paid, it's true. It will also give you the pre-image. Again, this is fake Lightning. We don't have pre-images in fake Lightning land, so no pre-image, and also it would give you the change back here, but again, no change, no fee, no real Lightning, so no change. But so you would see, this is why I said it's a little bit more complicated, because we have a multi-step process. First, you need to split your token that you currently have into your own change, as well as the proofs to be sent to the mint. So there is some change that you need to store in your database again. And then at the end, there's also change from the fee reserve, or might be change from the fee reserve that you might want to store again in your database. So Lightning is a little bit more difficult from the flow itself, but actually not too difficult as well, right? All right, and that was it. I think we're pretty much perfect on time. Just to close this off, a little call to action: get involved. The whole Cashu protocol, but also cashu-ts, is a open source group effort. We're always looking for feedback. We're always looking for contributors. So if you want to get involved with cashu-ts development, for example, here's the link to the repository. If you want to try it out and find an issue, please leave your feedback and open an issue. And I think it's fair to say that the maintainers of cashu-ts are aware that there are some issues with the library, especially when it comes to things like variable naming and stuff. So if you use it and you have some feedback, if you have some suggestions, please reach out to us, right? It's very, very helpful. And if you want to become a contributor, just go ahead, right? This is open for everyone. Go ahead, write some code, and let us know. Awesome. Thank you so much. Are there any questions?
Is there like a...
Is there a project that you point to as like the reference implementation of how to like do like storage properly?
Like what? Sorry?
Is there a project that you point to as like a reference implementation using cashu-ts that like does like storage or recovery properly?
Oh yeah. So actually yes. So there's multiple projects using cashu-ts. I think it's the main library in the JavaScript ecosystem. But if you would ask me personally, which is what you do, so I would go to cashu.me, which is the PWA developed by Kalle. And that uses cashu-ts heavily. It also uses the staging release often, so you can get a look at the most bleeding edge features, and they do like coin selection and everything in there as well. So
cool, thank you.
All right, cool. Thank you so much for listening.